Okay, today I'm going to show you what are the benefits of using MapleMBSE over product line, product structure. So first of all, let's have a look to product line. What are product lines basically? So product lines are hosting several products that are running in parallel. For each product, you may have different variants. And for each variance, you will have evolution over the time according to version number. Each time you change element in the variant, you will have a new version. These are the product line. Now, in parallel of that product line, you have the notion of platform resources. Platform resources are set up for sharing element assets that are potentially common to several product line or variants. And over the time, a given platform will follow the same model as the product line. Let's say it will evolve over the time according to a set of versions. Same principle. Okay, these are the principle of product line, product platform. Now, if we focus on a given variant, over the time, there are plenty of versions, and each version will be in a capacity to use or exploit part or all of the element coming from a shared platform resources. And that is true whatever the version. So from that, you will have plenty of combination of product line, variant, and platforms. And this overall scheme enables an efficient resource sharing among the product line. Now, if we look at that concept of product line platform resources in an MBSE environment, what happened? So basically, we are going to create a model associated to that product line, and this model for line and platform will be hosted by a centralized system of model that is called usually the authoritative source of truth. And that's a single point where you will find all the information related to a given model. Practically, who is managing that set of product line, product platform? These are usually managed by system engineering team. And their role is to build architecture and models in that central repository using the dedicated modeling tool. And this modeling tool is relying on formal language for describing in a precise way the structure and the behavior of a given system. So it is used in the industries to rely on SysML, that is an efficient language for describing behavior and structure of any complex system. And this, whatever the system is, it can be made of software, hardware, mechanical parts, or humans. Basically, SysML allow to build very heterogeneous models. So this is the role of system engineer, working in that modeling environment. But the reality is that in project, you don't solely have system engineer. You have plenty of other stakeholders in the field. And all that stakeholder may have various interests in different parts of the model. They want potentially to extract some information for their own business, because they can be project manager, lawyers, business, and so on. And all that stakeholder environment will be interested for extracting parameter, constraints, various information coming from that centralized model. And the goal is to extract that information from the modeling tool. The idea behind that is to make that information available for stakeholders in order to do their own daily business. That business can be feeding a simulation model, thermal simulation, spreadsheet of cost evaluation, all what you can imagine in the usual project. And once that information has been digested, interpreted by the stakeholder, potentially you may want to re-inject all the information as a result down to the system engineer the ultimate goal being to feed and update the model with that results. And usually that is done through the modeling tool, so via system engineers that are experts. Introducing that loop of feedback may lead to misinterpretation, critical error, miscommunication, and plenty of source of error that may be prejudicial for the overall project. And this is due because you don't have formal channel for rejecting data. And what MapleSoft is proposing is to introduce a new actor in the picture. So we keep the modeling environment that is still required by the system engineering team, but in addition, MapleMBSE proposed to insert a new brick that is called MapleMBSE, and that is made of set of, let's say, Excel file or Excel views that will allow to map some parameter constraint coming from the model and expose that information toward the project stakeholder. The goal is to kill that feedback and insert bidirectional communication through that Excel file in between project stakeholder and the model. So basically, this is what MapleMBSE is proposing. Through that Excel sheet, in fact, the project stakeholder may perform plenty of different tasks. It can be task-specific views, design changes, it can be trade studies, FMEA, it can deal with as well V and V compliant tests, all the task-specific that belong to the stakeholder that you can imagine for a given project. So now, if we look at the global pictures, where can we, in that picture of product line, product platform, insert the MapleMBSE prism? So basically it can be inserted wherever. It can be inserted in a transversal way against the version of the variance. And in that way you will be in position to explore the history of a given project through that Excel prism. But the key point is that you can as well plug that prism on the headline of the product version. And in that case, you will be in a position to contribute actively to the model through the Excel sheet. That's the MapleMBSE principle. So for the end user, it's a simple matter of playing with Excel sheet that will be interconnected with the model. And basically, most of the standard system engineering platforms are supported today: Rhapsody, Magic Draw, Teamwork Cloud, that will allow you to play with centralized SysML model through that simple Excel file. That's the principle. Let's have a look now to the MapleMBSE architecture overview. As said before, for the end user, it's very simple. It's a matter of playing with Excel sheet that represent the models. Through that Excel sheet, you will perform bidirectional exchanges, and that bidirectional exchanges will first go through a MapleMBSE component that is in the domain of a system expert. And that MapleMBSE component is tool agnostic and relies on two main components: configuration and template. And that configuration and template relies on advanced, let's say, script syntax. That's the reason why it is required to be addressed by a system expert. Once that's the configuration and template set up, that EMF-based framework will rely on various adapters, connectors that allow the platform to connect to system engineering platform, Teamwork Cloud, Rhapsody, and even Capella, the open source platform. So that's the overall view of the architecture MapleMBSE. Now let's have a demo, because we have seen the top level overview, and let's see how we can build a collaborative interaction through three different desktops. The first desktop of that demo is called desktop TWC. And through that screen, we will observe the Teamwork Cloud that is the central repository of our models. That central repository will be managed by an administrator, and the administrator will simply play with a standard web browser for administrating that platform. Aside that, there is a desktop Genesix, and Genesix desktop is basically there for demonstrating a Genesix actor playing with the centralized model through Cameo Systems Modeler. So this is the standard system engineering environment. And the third screen is desktop NCO. Desktop NCO involves the NCO actors that will interact with Teamwork Cloud through the MapleMBSE component. And that will be done according to several views that are represented in Excel sheet. That's the role of NCO, playing with that centralized model through MapleMBSE. And that's what we are going to see right now in that demonstration. Okay, so in that top level picture, let's first focus on the desktop TWC. So desktop TWC is an environment relying in the cloud. So let's switch in that on that environment. So I'm going to switch to that desktop, and this is the environment. So basically, there is an environment that is based in the cloud, and all that server today is running in the OVH environment, a French provider of cloud solution. And this environment is running an Advanced 3 hardware platform running a Windows server, standard Windows server, let's say. Reduce the window. And on top of that hardware infrastructure in the cloud, there is the details of the local server. And as you can see, that Windows server is mainly running 3 major applications that comes from NoMagic, the NoMagic Teamwork Cloud, Authentication Server, and the Web Application. So both represent the core bricks of our Teamwork Cloud. Now, if I look at the administration screen, that is through a web browser, there are plenty of applications that are available, resources, user, roles, and so on. And among all these applications, we are going just to focus on resources. So let's open it. I open the resource application in that administration interface. And now, if I look at the resources that are available, I'm going to see that there are plenty of resources that are available. And here there is one that is available for demo. And within that category, there are plenty of models that are centralized in the cloud available for demonstration. And today, we are going to focus on a given one, that is the TWC SysML SP3, the latest one. And as you can see, that model already has 3 versions in its evolution. Let's minimize the window. So here is the overall TWC environment that we have seen, and it is available for our 2 customers, Genesix and NCO, that will now collaborate. I switch back to the top level picture. And so we have seen that the TWC is the central part. Now let's switch back on desktop Genesix, that is the system engineering environment focused on Cameo Systems Modeler. Okay, so I'm going to switch on that screen, and on that screen I will enable Genesix user to modify the model through the application Cameo Systems Modeler. So I switch back to the new desktop. This is a Genesix desktop, and this is the usual environment of system modeling, so the Cameo Systems Modeler environment. So the first thing I need to do is to connect that local application from my PC. I need to connect it to the central repository. So for that, I'm going to use the Collaborate menu and login. So here I enter my username Genesix, and the corresponding password. And now I'm going to establish a connection to the server that is located in the cloud. I click OK. And we see here that I will be authenticated as Genesys user. So this means that now I am logged with the relevant username, and I'm able now to collaborate on system models that are centralized. So I'm going to open a model on the repository. So collaborate, I'm going to open the server project, and here the system is proposing me all the available models for modification. I'm going to select that one, the TWC, and the latest one, TWC SysML SP3. Okay, so I click on Open. This retrieve all the model information down to my PC locally. So I am filling my local cache with the whole model. And in that way, I will be in a position to collaborate and modify that model. Okay, so information are retrieved, and I can see, observe the usual SysML environment with plenty of screen that represent my model. Here I have the toolbox, and here the database of elements representing my model. Okay, so this is the usual way for system engineering to work, and then I can build and modify the architecture of my system using SysML. Now I'm going to focus on the special part of that project that is called the model fitness tracker. Okay, here as you can see in that model there are some activities, requirements with nested requirements, a structure describing the structure of your system in terms of blocks and interconnections, and the latest is use cases that describe high-level use cases of my system. Okay, this is my environment. So now what we're going to see is that it's possible to interact with that centralized model, not only with that environment of expert, but as well with the Excel sheet provided by MapleMBSE. So now we are finished with that screen, and we are going to switch back to the overall view of the demo. Okay, so we have seen that central screen, the desktop GSX, and now we are going to see how through that desktop, how the user NCO will be able to be connected to that centralized model. So I switch back to that screen, NCO, and let's see how that new user will connect to the Teamwork Cloud. Okay, so what I need is to switch to the desktop. So let's switch. And here, let's have a look to the organization of that desktop. So the first thing that will happen is that we need, prior to any connection, we need to configure something as said before. The two first things that we need to configure or create are the Excel template and the MSE configuration file. And that MSE configuration file is written in a dedicated language, and the goal of that file is to define how the information retrieved from the model will be spread in the right cells in the Excel file. Okay, so this is the first thing that we are going to look at. So I have plenty of different files and different script files that are available. I'm going to focus on that particular one, that .mse file that dictates how to fill that Excel sheet. Okay, so now I'm going to open that MSE file, reducing that screen, and be focused on that file. So this is the content of the file, and as you can see, this is a text file that contains syntax element written in a dedicated language, and it is, let's say, the complex part of the environment. And this one needs some expertise for mastering the complexity of the language. And that language is there for precisely defining how the information will be spread in the overall spreadsheet. Here, for example, you can see that we are targeting with that special script only one part of the model, the fitness tracker, and we are going to explore the three main packages. Okay, I reduce the screen, and now let's focus on the corresponding XLS template. So that Excel template associated to that MSE file have the same name, and if I focus on that XLS file, let's open it. I put it the file's full screen, and it's as you can see, it's a standard Excel file. So that Excel file is just there for defining the template. So how I want my data to be presented for the end user. I have plenty of sheets. For example, the package sheet. Here I will present the list of package name and the associated visibility. As you can see, everything is empty. Here I have a second template file sheet representing the requirement organization with different level of requirement, name, specification, and the dependencies. Here, this is an example of table that simply lists all the actors. Here, all the use cases, all the structure of the system. Here, another structure, and here, a dependency matrix that is there for representing the dependency in between blocks and the requirement. And all that table will be built dynamically using the MSE files that we have seen just before. Okay, and that's the role of the MBSE tool, to rely on both MBSE and that Excel template. Okay, so these are the two first elements that you need to configure prior to actually launch a connection. So once that has been defined correctly, we can launch the connection to the server. So for launching the connection, I'm going to double click on that MSE file, and this will launch the MapleMBSE Prism against the model. So I double click on the file. This launch the standard Microsoft Excel sheet, and here I have the dynamic construction of my sheet that is starting. It launches first panel for selecting the right libraries for interpretation. So I select the first one. This is one of my installation. I click OK, and then it opens the connection windows for logging to the server. So here I'm going to try a connection with NCO username. I write down the corresponding password, and it will make the connection to the server. Okay, once the connection is established, the system proposes me the available project. I'm going to select the last one. I connect to the server, and I retrieve now all the information from the server down to that spreadsheet. Okay, the table is dynamically loading. Let's wait. I'm going to put that in full screen. Okay, so here I have my spreadsheet that is being filled dynamically. So if I look at all the available sheets and I switch to package, the first one, I can see that here I have all the different package name that has been extracted from the model. So activity, requirement, structure, and use cases. For the requirement tree, I have that sheet that has been fed automatically with the data coming from the model. I have the actor list here, all the use case and their dependencies. I have as well, for example, the block satisfies matrix that is loading. It's a bit more long, okay. And that presents the dependency in between blocks and requirements, or which requirements satisfy which blocks. So a pure tabular way of visualizing the dependencies. So all that information has been filled according to the instruction provided in the MBSE file. So if I come back, just for the example, on the packages, here I can see 4 packages: activity, requirement, structure, and use case. And if I switch to the Cameo Systems Modeler view, the Genesis standpoint, so I switch on the other screen, and on that screen, if I put that in full screen, let's have a look to the model fitness tracker. And as you can see, that model is made of 4 packages: activity, requirement, structure, and use cases. So the same as the one we have just observed in the other desktop: activity, requirement, structure, and use case. So it's just a different way to present the organization of the model through Excel sheet. Here I have plenty of requirements and their nested requirements: level 0, mission requirement fitness tracker, and level 1, capability, compatibility, performances, features, and so on. And now, if I switch back to the model observed from Cameo Systems Modeler, if I open the requirement folders, then I can see that I have that requirement level 0 and the nested requirement, compatibility, display, feature, performances, and below all the nested requirements. So it's exactly the same view, but presented in a different way. Here it is through a SysML organization, SysML model, and on the other side it's through a pure tabular form. And now what we are going to see is how to exploit and potentially perform modification from that Excel view. Okay, I come back to my demonstration screen. So we have seen that centralized model that hosts all the shared model can be accessed either through Genesis via Cameo Systems Modeler or through MapleMBSE by the NCO user. So once that 2 connections are established, now let's see how the user NCO and Genesis can both collaborate concurrently on the same model. So I switch back to a new sequence of demonstration, and here we are going to be focused on that collaborative work. Okay, so now I'm going to switch on the Genesis screen for demonstrating how to modify the model. Okay, here I am back on that screen, and I'm still logged out as a Genesis against the model, and now I'm going to start to do some changes against the model. I'm going to open the requirement table of the fitness tracker that presents me everything in a tabular form. I'm going to close the useless windows. Okay, so here I have the table of requirements exactly as it appeared in Excel views. But now I'm going to perform some slight modification against requirements and see how it is perceived from the NCO environment. Okay, so let's focus on particular requirements, for example, the performance one. So if I look at that element, I can lock it for editing. Okay, now let's locate that element in the central database. Okay, here is the element. I open the specification, and now I'm going to see in that specification window the name, that is Performance V2. Let's change it for Performance V2. Sorry. So I close it. I have changed the name. I save the model here locally. But so far, modifications are not yet pushed toward the server. So if I switch back on the NCO screen, I can see that here still the name of the requirement is performance. By the way, I can check that the version is version 3 here. So I have the view on the version 3. And if I switch back to the Cameo Systems Modeler, I can see that here I have the view on the version 3, but locally modified. Okay, so I'm going to do a commit against that model for pushing the modification down to the server. So I open the commit window, I write down the commit text, change name for version V2, and I'm going to push the modification through that commit. Note that we are in version 3, I push the commit, and you will see that the version will increase by 1. So information are pushed in the cloud, and now you can see that we have switched to version 4. So that means that the information are now available for any other user that are allowed to contribute on that central model. So now I'm going to switch back on the NCO screen to see how we perceive the changes. So here I am in version 3 through the MapleMBSE Prism, and still the name is performance. So I open a dedicated menu for reloading, updating the current view against the latest version of the model. And here you're going to see that that performance name will change to the latest name. So I click everything OK. I know that it's dangerous. Okay, performance is now performance V2. This means that I am now in line with the latest version or coming from the server. And this demonstrates that there is a collaborative scheme that is possible in between two different users, each of them evolving in its own world, let's say, either Excel or Cameo Systems Modeler. Okay. Now in that environment, I'm going to see how we can potentially do modification in the reverse way. So from that Excel sheet, I can, as an NCO, do some modification against that version. So I'm going to stick on that cell and perform some changes from that MapleMBSE environment. So I just change the name from performance V2 to V3, and as you can see, all the name here has been changed, and that's normal because all that cell represent the same object. Now I am in version 4, so I'm going to push that modification toward the server. For that, I double click on the save button, and while double clicking, it opened me a commit window. Here I write down the command for that version evolution, and I will be in a position to push everything down to the server. As you can see, I can even play with branches. I will not play with that today. So I click OK, and this will push the server, and it increased the version to version 5. Okay, the modifications are now in the server, in the cloud, and I am going to switch back on my Genesys environment and update my model for being aligned with version 5. So update project. Information are retrieved from the central model, and you will see that here the name will change. Okay, model is updated. I'm going to see that, okay, I am aligned, and now I retrieve the information from the central server and its performance P3. I can even just look at the project history. So I open the project new, and among all the available projects, I will look at the history of my current project. So I open the history, and from that window, you will see that the history of that file show that there are two contributors, NCO, that performed the latest modification, and the other is J6, the system engineer, working on the Cameo Systems Modeler. So we have two users working in two environments against the same model. Okay. So this demonstrates that we can collaborate actively using these two environments. Okay, so now let's see how we can add new element, not only perform modification, but add new element from the MapleMBSE environment. So for that, I'm going to switch to the other environment, the NCO1. Okay, and let's work, for example, on the requirements. So here I have the original set of requirements, and I'm going to try to insert a new requirement from level 0 and two nested requirements. So here I simply play with the Excel sheet and I write down a new requirement R2. For that, I'm going to fill the name of that requirement. So a mix of French and English. Nouveau requirement for demo purpose. Okay. And this is the requirement of level 0. And below that requirement, we want to build two nested requirements. So at that level, I want to build another requirement. For that, I'm simply copying the line or the key of the fresh new requirement. So we do a copy paste. Okay, copy paste. And here I write down the name of the nested requirement, R21. And if I want to insert a sub-level requirement below that requirement that I am naming A, I will do the same stuff, copy the line, okay, and go at the level down here and write down the new requirement that is nested to requirement R21, so R211. Okay, so here it is, and now I'm going to name it A1, for example. I'm going to write down the specification of that low-level requirement, demo text specification. Okay, that's it for here. So I have done the modification, and I need now to push that modification onto the server. So for that, I am going to update the server project with that spreadsheet. Okay, so how to do that? It's quite simple. I'm going to double click on the save, write down the commit message, and so add new requirements from NCO user. Okay, I push OK, and this will increase my version to version 6. And now I switch back on the system engineering environment, the Cameo Systems Modeler, and I will update my model. So prior to update, let's have a look to the requirement set. And as you can see, there is only one requirement of level 0, mission requirement fitness tracker, and no other requirements of level 0. So I click on collaborate, I update the project, and now I will observe, as soon as we'll be in version 6, that there is a new requirement of level 0 that is called nouveau requirement for demo purpose, with the requirement level 1 called A, and the third requirement AA1. Okay, and if I open the specification of that latest, I can see that the text of that requirement is demo text specification. Okay, so this demonstrates that I am able to insert a brand new model element from the Excel sheet directly in the MapleMBSE environment. And this was a very simple example of element insertion, but you can imagine plenty of more complex table that will allow you to insert complex set of elements and relationship. Okay, now I'm going to modify that one for changing some cosmetic stuff. I made some mistakes or typos, so I changed that with the right name, because I am French and it's sometimes complicated to write down requirements. And here is the level A, here is the name AA1. Let's, for example, rename it requirement with the name B. I lock it for edit. Okay, it is locked. Now I'm going to open this corresponding specification, or change the name directly. Let's then rename it requirement B, representing the latest level. Okay, here I am saving the project locally. Now I'm going to commit the changes. I push that down toward the server, changing name plus cosmetic update. And now I commit everything to push the modification toward the server. The version here will increment to the 7. That's okay. Now I switch back to my NCO window and I will observe the modification on the corresponding spreadsheet. So here I'm in version 6. I reload the model for being on version 7. And I will see that that typo will be modified, and the latest requirement has its name that is changed. So I have closed